Hello everyone, welcome to this presentation. Today I'll be presenting about my research on designing a novel family of class EF inverter for improved efficiency. So basically in this research we have designed a novel family of inverter, and the inverter is as you know is to convert the DC into AC. So in this work we have already completed the complete simulation, and we have completed the experimental testing. So in this presentation I'll try to explain this work in very short, in a simple way. So first off, I'm as a professor in Tripoli. Will be presenting this work for my group. So in this presentation I'll be discussing about the background. I'll talk about the objective, the proposed converter, the operation of this converter in short. The results section, I'll discuss the results, both experimental and simulation, and the future plan. So to discuss about the background of this project, first you really need to know what is a class E inverter. So as I have said before, the inverter is to convert the DC into AC. So the class E inverter is initially primarily was designed as an amplifier, as an power amplifier, that is to amplify the power, like in audio devices. In very early stages of this inverter, it was primarily designed as an audio amplifier, and it was first proposed by Kazimierz. He actually invented this inverter. So class E, the advantage of class E inverter is that it's a very simple design. As you can see from the picture, it has a DC voltage source, it has input inductor, a switch, an input capacitor, and an LR and CR, basically a resonance circuit, and the output load. So if you give a DC voltage here, you can get an AC voltage at the output. So the advantage is that it has a very simple design, it has a very simple configuration, it has number of components are very low. So this is its advantage, but as you know, it's a very old design, so it has some disadvantages. So people later, the researchers later, have proposed many modified version of class C inverter. Let's see. So the resonant part here is the main part of this inverter, which really converts the DC power into AC power. And as I've said, the problem with class E is that it has a very high switch voltage. Now you can see a switch here, S1. You can see the switch. It actually operates in two modes. I'm not going into the detail of this, but you can see a switch here, and the voltage across this switch becomes very high. Say if you give a 10 volt input, the voltage across the switch might get to 100 or 150 volts. So what's the problem with that? The problem is that if you have a very high voltage across the switch, then you really need a switch that should have or must have sustained that voltage. So that means you need to select a component or a switch that can sustain that voltage, and that means the switch will be very expensive. So now if you say you are giving 10 volt and you need a 10 volt AC output, you are giving 10 volt DC input, and you need an 10 volt AC output, so you need a switch that must be able to sustain hundreds of volts. So for a maybe your other components are very small, it can be set in a very small space, very small, very compact, but this switch will be very large, and this will be very expensive. So this is a great problem with the class C inverter, which the later researchers have tried to solve this problem. Now say if you are using this inverter into your laptop. Now say if you are using this inverter into your laptop, the laptop size will be bigger. So if you need a big switch, the laptop size will be bigger. So I'm just giving an example. Okay, so the voltage actually can become 3 to 5 times larger as compared to the input voltage. So if you have a 10 volt input, the switch voltage could be 50 to 100 volts or more than that. So To solve this problem, the researchers have developed new type of inverter, which is called EFn. You can see a single N here at the subscription, single N. This is a new type of inverter, and this type of inverter actually can reduce the high switch voltage, and also it can improve the efficiency. So there are different type of inverters that has been proposed so far, like class EF2, EF3. It's a different type of inverter and different type of configurations. We have done detailed research. We have done a comparative work on that, how this inverter compare as far as if we consider the switch voltage or efficiency, but I'm not going into that. So this has been different type of inverters have been proposed by the researchers, and these inverters actually can improve the switch voltage, can lower the switch voltage, and can improve the higher the efficiency as compared to originally developed class C inverter. But still, these inverters has other problems. The problem is that this type of inverter, class EFn and EFn/n inverter, this type of inverters shows very low efficiency. Now this paper you see, I'm taking the reference from 2006, might be transaction industry electronics. So they have a very low efficiency. So we have successfully increased lowered the switch voltage, but by doing that we have also lowered the efficiency. This is a great problem. So our objective was that we will develop an inverter that will lower the switch voltage, and also that will maintain or improve the efficiency of the inverter, and also that will have higher stability. So these are proposed inverter. In this inverter or converter, whatever you say, we have used a multi-winding transformer, and we have used two resonant circuit, and these two resonant circuit will be transferring to different frequencies, and we have used a single transformer, and this single transformer will transform the power from both of the frequencies. And this is our simulation circuit. We have simulated the circuit so far, and we have got simulation results, as I am going to show you. On the left, we have got the input voltage. As you can see, if we change N or M, it can have different value. So if it's a EF23 inverter, that have a very you can see the input current of this inverter, and you can see the switch voltage. And also we have simulated the circuit. We have got the output voltage. You can see is a very smooth AC at the output, and we have got the resonant currents at different frequencies. So we have got three resonant frequencies here, and also we have got the result for EF32 inverter. That is the input voltage and then the switch voltage. We will see a comparison later. And we have got the output voltage, a very smooth AC, and the resonant currents, as you can see. Also, we have tested this circuit experimentally, and on the left we have got the switch voltage EF23 and the output voltage for EF23, and the switch voltage for 32 and output 32. And we have come to the point that we have already published this paper in STI, and as we have said, we have already developed performed the experimental testing, and we have found that our inverter can be able to reduce the switch voltage as compared to class C, originally developed class C, and later improved class EFn or EF/Fn, and it can also sustain the higher efficiency for all operating conditions. So as you have, if you compare, see, we have got all the results here, and we have got very good efficiency also. So in future, we might have used piezoelectric transformer in our design that will be very make the inverter more compact, and you will be able to use in more small electronic devices. Thank you.